and welcome to the video on chemistry for life. Let us start by discussing some terminologies. Now we know that all matter is built up of simple units called atoms. Now although the word atom means something that cannot be cut, uh, these elementary particles are actually made up of smaller parts which are themselves further divisible. Now, elements are substances that consist of same kinds of atoms. And compounds consist of units called molecules, which are intimate associations of atoms, joined in precise arrangements. Now, atoms interact with one another to form chemical communities. The tightly knit atom making up the communal molecule are held together by chemical bondings. Now let us look into the bondings. Now one way of achieving this more stable state is for an atom with very few electrons in its outer shell to donate them to an atom with an outer shell that is almost complete. Now the atom that donates the electron will then have more protons than electrons and assume a positive charge. It's called a cation. The atoms receiving the electrons assume a negative charge and hence is called an anion. Now these two oppositely charged ions are electrostatically attracted to each other and are said to have ionic or polar bonds. Another way in which atoms may join with one another to bring about a filling of their outermost shells is by sharing a pair of electrons. Now two bonding atoms provide one electron each in creating the shared pair. This pair of electrons form a covalent bond that holds the two atoms together. It is represented by a solid line in the formula of a compound. In many molecules, covalent bonds may occur not just single but involve the formation of double or triple bonds in which two or three pairs of electrons are shared. These double and triple bonds tend to fix the position of participating atoms in a rigid manner. Moving to non-covalent bonds or ionic hydrogen bonds. They are much weaker than the covalent bonds, and so protein shape can be disrupted especially by temperature, pH, or ions or salts. It involves more dispersed variations of electromagnetic interactions. Critical in maintaining the three-dimensional structure of large molecules such as proteins and nucleic acids. There are four commonly mentioned type non-covalent bond interactions. There are hydrogen bonds, ionic bonds, van der Waals forces, and hydrophobic interactions. Now the non-covalent interactions hold together the two strands of DNA in double helix, stabilize secondary and tertiary structures of proteins, and enable enzymes, substrate binding, and antibiotic antigen association. That is it for this video. In the next video, we'll be talking about the combination of bio and chemistry. Thank you.